This is the final test of 41504, which is a phase linear. Get some light on this too much. 700 series 2. This came in with a lot of problems. Both channels were not functioning. One channel was drawing so much current it was popping the fuses. And pretty much has been rebuilt. It works great now. And so what we're going to do is connect it to our test panel. We're going to feed in some normal audio like a person would listen to on their stereo. And then we're going to feed in some tones. And we're going to monitor those tones on a dual trace oscilloscope, which is, let's even get my hand over here. There we go. The lower display is going to be the right channel. The upper display is the left channel. And over here, there'll be two horizontal bar graphs. The lower display will be the right. The upper will be the left. And that second device is going to show us amplitude in decibels when we do a frequency response test. So we're going to turn this on, and what I'm going to do is if I turn the power up higher, it's going to distort this microphone and drown out my voice. So if I do turn the power up higher, we're going to go into what is called dummy loads. Dummy loads stretch the item the same as a speaker, but convert the audio energy into heat rather than audio. That way we don't destroy my ears, overload the microphone, or anything else. Okay, so here we go. Let's turn it on. And there, we're going to turn it up a little bit.
Platinum battery until February 26th.
Hopefully that's not too loud.
At Advanced Auto Parts and participating CarPlus locations. Free installation with purchase, most vehicles, most locations.
Wendy's has been showing everyone how to do fast food right for 50 years. And now they're showing them how.
So what I'm going to do is switch over to sine waves. And we're going to step this thing through the entire audio spectrum. And demonstrate the relatively flat frequency response. So we're going to go over to the sine waves, which are, I can't see what I'm doing here, but nothing unusual there. And we're going to go over to here, and that is the left channel again, that's the right channel. And what I'm going to do, I'm going to turn this down so you can hear me. What I'm going to do is turn this amplitude up so it both left and right channel are the same on this device up here with the horizontal bar graphs. And we're going to set it to 0 dB, and then we're going to go through the entire audio frequency. One of the things that I'm going to do right now so I don't have to yell over this is go into the dummy loads. All right, so we're still stressing the amplifier, but we are able to talk and not compete with the sound. So there's left channel. Whoops. There's left channel, and here's right channel. Oh, we're drawing some serious current here. And so what we're going to do is start at the lowest end of the audio spectrum, which is going to be, this device does this in steps. So that's about, I don't know. Start to 20, and we're going to go to 20K. All right, so right there is 20 hertz. And we can change the time constant on the scope so you can see the period better. But as we change the frequency, the period is going to change also. So there's 20. Let's step it up. There's probably 40, somewhere around there. There's 60. And notice the period is changing. What we're really looking at here is the bar graph. They're staying the same. Frequency response is not changing as we are increasing the frequency. Again, we're going through the audio range on this. What are we up to here? We're up to, that right there is 6.3K. And we're still flat. No, change whatsoever on the horizontal bar graphs. Now let's go 6.3. Whoops. Sorry about that. Whoops. Really sorry about that. Not easy to do in the dark here. There we go. All right, let's continue our journey. There's 8K, around 10K right now. And we're starting to drop off. We've lost about a decibel per each channel, but we're also at 20K. So across the entire audio spectrum, it's flat up to it's flat up to about 18K, and then as we go to 20K, we lose almost a decibel, which we're talking about next to nothing here. So let's get this back. I'm going to turn the speakers back on. This may be very loud. Oh, this item had so much wrong with it. There were front end on the amplifiers uses a JFET op amp on each amplifier. One of them developed severe internal problems, and it loaded the regulated power supply so badly that it affected the other channel's op amps. So the one channel with the severely damaged op amp took out a couple of output transistors and was blowing the fuses. The other channel actually functioned, even though the plus or minus voltages going to that op amp were not correct. Replacing the defective op amp stopped overloading the regulated power supply, which brought the other op amp up to proper biasing. And what I did was replace both of the op amps with a newer, lower noise op amp. And this item is very sweet now. Very, very sweet amplifier. That's going to be the end of this demonstration. And we've saved another one.